I'm Balázs Tóth, and actually I'm working together with Arjan Kleij in his laboratory, and we started to work on the mercury just in 2020, and I contacted him just before in April, and that was from there a continuous work for us. What I would like to highlight regarding the mercury, it's really competitive, highly competitive fellowship, and it means a long preparation. So from April until September, until the submission, I work continuously on the project. So how to develop a scientific idea to make a project feasible. And in this time, I think people or the candidate can learn a lot about the scientific communication, also the synergy, how to have knowledge transfer between the researchers and the institute. So I found this is, in ICIQ, this is more like a cooperation or a continuous work together. That what we can say here is the ICIQ took care about the full administration of the project, what was really a nice and a relief for me. And we worked more on the research, the chemical part of the fellowship or the project. And in meanwhile, it is really important to have the knowledge transfer between the researcher and the group where he or she would like to join. So in this way, I think it's important to bring new knowledge, to have the synergy, and also the researchers by the Mercury Fellowship and the continuous work will have the knowledge from the group from chemical point of view, and also from soft skills like how to manage a project continuously, how to supervise work together with a team. And there are many options for example, workshops. So for example, I attended the Leadership in Action, and also I had the chance to learn a bit Spanish in a Spanish course, for example. In the frame of the Mercury project, we started to work on dual catalysis. That was the chemistry. So photoredox-controlled dual catalysis. And we wanted to transform electrophilic vinyl cyclic carbonates to combine together with hydrofluoroolefins, what we figured out in the beginning. These hydrofluoroolefins can be considered as fourth generation refrigerant gases. So it's used for air conditioning systems as the coolant agent. So it's produced in 100,000 ton scale, but there are no methods to transform these chemicals for very well fine chemical industry. And we targeted to transform with this methodology development these chemicals to make a coupling reaction for valuable things. As we started the chemistry, we figured out that this is very difficult and the coupling didn't happen. But in the meantime, we found other interesting reactions what we could investigate further. And it's really good in the Mercury Fellowship that the researcher has the flexibility to extend or change the direction of the research. And I had the privilege to find another interesting or maybe more interesting coupling reaction.